Hello everyone, welcome to this video. In this video, if you are given G as some group and H be given to be this set which consists of all the inverses of this group. Suppose if you have X element taken from this group G, then its inverse would be present in H, right? So you need to show that this group and this set H, they are equal to each other, right? So let's prove this thing. So we are not saying that this H would also be a group. This is not what we mean by we mean here. In fact, we need to show that they would contain the same elements within it, correct? So what we need to prove, we need to prove that G is equal to H. So we'll be doing that by showing first of all that H is a subset of this set G, and then we will show that G is a subset of this H, correct? So we'll prove this thing one by one. For the first one, what we do, we take some element X from this group G. Then obviously by the definition, because if you have some element X is in G, its inverse would be there in H. So X inverse is present in H. However, this X inverse is also present in G. Why? Because G is a group and it contains the inverse of each element within it. So therefore, if this H inverse is present in H, it is now also present in this G. Hence H is contained in G for all X. Why? Because we have X as some arbitrary member, correct? So let's park this as equation 1. For the second part, where we wanted to prove that G is contained in H, right, we will take some element from G and show that it is also present in H. So let's take that element to be small a. If small a is present in this group G, because G is group, so its inverse would also be present here. If its inverse is present in G, so this is some element in G, right? Let's call that by B. So that means if you take the inverse of B, it would be present in H. That is what I have written over here, correct? So by the definition, it would also be present in H, correct? And when you solve this, what is A inverse of what is the inverse of A inverse? It is simply A. So we have G contained in H, correct? So from equation 1 and from equation 2, we can clearly say that the set G is equal to the set H. Hence, this is what we need to prove here. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.